Right, well, welcome to today's webinar, which really I'm focusing on the life cycle cost analysis. Now, it's certainly not going to be a graduate level course on this process or qualify you as a Master of Business MBA. I don't even know what MBA stands for. I've used the acronym so long I don't remember. So good morning, Christine and Vinay. Thanks for joining. I'm Fred Schenkelberg, and this is just a one in the series of the Ascendo Reliability webinars. So everybody is welcome. And please use the chat window, as some of you already are, to ask questions or comment. And I'll get to as many questions or as we're going through the presentation. And so I look forward to, if you've attended one of these before, you know I try to do as much conversation and interaction as I can. And so, but the idea of being a reliability professional is not just doing accelerated testing or field data analysis or FMEA or the many other tools that we're doing. And it's what we do and how we work as reliability professionals, it really does impact the business, and people make decisions based on what we do. It's in context of what's important to the organization that you work with, whether it's a private industry business, a publicly held business, a charitable organization, or a military facility or organization, is that we usually have some outcome that is the driving purpose for our organization. And keeping that in context for what we do as reliability professionals helps us, one, to make sure we deliver what is useful, but two, is it helps us to actually understand what it is we're trying to influence or contribute to. So having a good sense of what we're about as a business is important, rather than just being heads down, cranking out another prediction. And so it's a little bit of both. So I see your question, Sean, and yes, there's a side deck. You have to click the download file. It may open a different browser. Okay, so you're answering the question for Anthony. I see that. Thanks. And I'll bring the set of links up at the end of the presentation, so you'll see it again. And if you're listening to the recording, you can find it at reliability.fm underneath the Ascendo Reliability webinar series, and this particular webinars show page basically will have links to it. So beyond having a sense of what we're about as a business and how our work fits into making decisions, is keep in mind that we really are faced with limited resources to accomplish whatever it is we're trying to do, to bring a product to market or improve a product development line or product line or a factory line or our process or whatever it is. We're not blessed with unlimited resources in most cases. We may have limitations on funding or money, on laboratory equipment, on time, on know-how even. And so understanding and working with the limited resources and showing our justification that, yes, doing this accelerated life test is going to add value and it will be worth using these limited resources, is part of what this life cycle cost analysis is about. So in some cases, the analysis is done for the customers and the end users of the product. Will this product meet your cost of ownership requirements? But internally, most of us are working within an organization and we're competing for resources. And so our ability to provide information that actually helps people make decisions that what we're doing adds value, all the better. So if you've seen, I think I've done a couple of different webinars that talk about estimating value and calculating value. And if you're a member of the Ascendo Reliability site, under ebooks, you can find an ebook called Finding Value. And it talks about a dozen or so different ways to estimate value for specific activities. And so a big part of what we do is not just crank out another FMEA and pull a team together for a couple of days and set us a bunch of priorities. It's it has to actually change how the organization focuses or reinforce what we already are doing. It may provide new insights to what's failing, and that adds value by helping us solve things before they cause problems or we find it late in the program. It also adds value by coordinating and aligning the organization or the team to focus on the most important things to resolve for and as we work to improve reliability. So those are two different threads for estimate or providing value, but we have to also need to quantify that, actually put a number underneath that to say this is why we're spending all this time with these very talented people to do an FMEA, for example. So in today's presentation, I'm not going to get into some of the more esoteric value calculations. Take a look at the book Finding Value for lots of ideas on how to do that. And some what I need to do is add some more models to that. So lifecycle cost analysis is one of those tools that is commonly associated with systems engineering and may be already done by the financial group in your organization or by somebody else in the organization. But they're doing it for the product in general or the product line or the factory equipment and sizing and purchasing major capital equipment and all kinds of different reasons. It's not an uncommon tool. It is really, really useful to understand the basics of it, though, as a reliability professional, as you're looking to get your proposals adopted. If you need some test equipment, if you need to replace some equipment, if you need to change your product to reduce its chance of failures in the future, those things all cost money and time to implement, and we need to justify that. So a life cycle cost analysis is a good approach to help you quantify the justification. And we'll get into some examples and a little bit about the different ways to do this at different stages in your programs. So let's take a look at something I enjoy a whole lot. Instead of replacing a piece of factory equipment, when I was developing the slides, I was looking for my second cup of coffee. So talk about a coffee machine instead. And got a couple people joining here on the phone, so I need to mute those. For whatever reason, when you dial in or have the system call you, it doesn't mute the line. But anyway, let's say I'm interested in replacing my coffee equipment in my coffee shop with a new machine, and it costs about $5,000. But the benefit is that it looks like it's going to have less maintenance, and in two different ways. One is I don't have to clean it every day. It has some nice features to it, and it only needs to be taken offline for about an hour a week instead of an hour a day. And there's cost associated with the person, actually the labor of doing the cleaning. So there's a little bit of cost saved every day, every week practically. And then there's also, we've known from experience and what we expect with this new equipment, because it's about the same complexity, is that it may have it may need major repairs a couple times a year. But the new equipment was designed with repairs in mind so that you could have spare parts and do the bulk of the major repairs in-house. You don't have to ship it away for a week, which would take it offline. So the new machine seems like a slam dunk. Yet my boss said, well, what's the payback? This is $5,000 and yeah, it looks like a good idea, but what's the real difference? How do I justify making this capital expense? Now, you can translate this to examples in your own organization or factory, but the ideas are the same. Well, there's benefits, and at this stage, they sound good, but there's no numbers underneath it. So let's dive into it a little bit more. All right. So we know that cleaning the equipment that we have now and we expect with the new equipment will cost us about $20 an hour. So a little bit of labor and maybe some materials that go with that. So it's a rough estimate of the maintenance cost. And we're going to save about 6 hours a week. It's going from an hour a day to an hour a week, saves us about $120 a week or $6,000 a year. Now, in some cases, this might be enough to say, hey, that's saving more than the cost of the machine, so that makes sense. But is it enough to justify switching over? Is it enough of a savings given the uncertainty of our estimates? Right? Yes, and Sean, the idea is that the new machine does take some cleaning, but it takes less cleaning. It had a simpler type of setup, for example, or it was designed to be self-cleaning in some of the areas that required the daily process. So now it's only weekly that we do this. And it might be changing filters or cleaning the water intake or something like that. But whether it's like your car, you're taking it in for an oil change. And as the oil and the designs of engines have changed, instead of every 3,000 miles, it's now common to see every 5,000 miles and sometimes longer. So it's an improvement that was made that allows us to save on the routine maintenance, for example. But the point here is that if it's at an estimated over a 1 year period to save us $6,000, when I first brought that back to the coffee shop owner, he said, well, I mean, I could put the $5,000 in the bank and, well, not today with today's interest rates, but I have other investments that could do better than that. So how else can this help us save money? Well, if you recall, there was the time of downtime. So the old machine, which was a unique machine for our shop that produced a particular type of cup of coffee, when it wasn't there, we couldn't sell those, and there wasn't a profit associated with those. So conservatively, we're estimating that we lost about $50 an hour when the machine was gone. And the new machine produces the same kind of fancy coffee that has a decent profit margin, and we would recover instead of a 7 days being down or 5 days being down and losing all of the profit from making this particular style of coffee, we could do the repair much quicker and be back online and selling coffee at this better profit margin. So that's a real cost that when we change the ability to make repairs, it makes a difference. So what we're looking at, and let's see if I can bring up my drawing pad here, is the new machine costs us $5,000. And so that's this block here, 5K in cost. And in the first month, it's going to save us about $480. We'll put that on the profit side. And in the second month, it'll save us $480 and so on. And if I go across here, it's going to save a total of $6,000 over the year. Now, let's say that there's going to be 2 repairs that we avoid the loss of the profit. That net savings then is about $3,000 or $3,500 each time that occurs, and so on. And so in that month, I also get the cost of the savings that's associated with the cleaning and so on. So these are all plus sides. These are the savings that end up staying in the register or in our profit market or profit side rather than being an expense. And the idea is at some point I hit the 5K of returns that is a break-even point, and at some point I might have even twice as much, 2 times the cost of this machine. And one of the questions that we have to ask, whether it's the owner of the coffee shop or it's the the financial analyst, or is this being compared to other services, is, well, how long does it take before I break even? And how long does it take before I have a 2 times the return or 10 times the return? In some businesses, 10x is considered the return on investment that makes it a good decision. And so I learned this, I don't know where, this process of drawing out a timeline and drawing the cash flow out, here my investment, and then the cash flow in as it comes in over time. And looking at this balance basically as to when I break even and when it becomes a competitive proposal versus other options we may have available. And it helps to think through the decision is, well, what's the changes in the actual cash flow or the other benefits that germane to your particular product? It might be throughput, for example. Then you can work out, well, what does it make sense to make this decision and buy the new machine? Now, if you're like me and really enjoy coffee, you might just buy it anyway because you want the latest, greatest. But most businesses don't operate that way. And most of us operate in much more complicated situations where just going off and buying a new piece of equipment is not a slam dunk. You really need to justify it. Well, part of this process, though, of a life cycle cost analysis is understanding the different life cycle stages. Now, you may well have your own life cycle stage program or checklist or product development process or project development process. And I found in so many organizations that they have a very similar process with different names and all kinds of creative names. But one of the stages, and this should be a quick review, is the concept planning. Geez, is there a better way to make coffee, for example? And as a reliability engineer, one of the key things we do is help the organization set the goals. What is it we're trying to do? What is the goals and objectives from a reliability point of view? But also then start to identify the major blocks of risks. And we start laying down initial plans. So these initial plans is where we start scoping out what's our cost and what kind of resources we need. And a savvy reliability engineer will also start looking at where the barriers are to getting those resources and start developing this life cycle cost analysis approach to justify the implementation of the plan we have and getting the resources we need. It may not be formal at this stage, yet this is where we have a pretty large impact on the eventual reliability performance of, say, a product that we're about to develop or the machine we're about to bring into the organization. So another stage is the actual design and development. And so this is where we're putting together the solutions, we're building prototypes, we're looking at building out the supply chain and how we're actually going to build the product and all those major decisions, all of the design for reliability, design for manufacturing, design for X, basically, all happens here. This is where we have a lot more competition for those resources. So if you want to get prototypes to do, say, environmental testing, because it's important to understand where the margins are in some of the areas that the team has identified as risks, then, well, those cost money. And there's a lot of competition for those prototypes. So by being able to say, if we can identify and resolve issues related to, say, high temperature exposure, because we know that this product will see high temperatures in some of our cases, it's, well, working out how many will see that and what would the potential impact to failure rate be. And right there, you have the basis to create a life cycle cost analysis, a future probability of failure, and a bit of uncertainty that the testing will help us resolve. So if you present to the team that approximately 10% of your units will fail if they're above 50 degrees C, but we don't know for sure because we've never evaluated it there, If we get a prototype that may cost us $50,000, we can find information that help us resolve what the true probability of failure is. And then we have a branch that we either fix the design or improve the product, or we accept that failure rate, whatever that value is. But we then make an informed decision rather than just a guess. And the value is in that reduction of the uncertainty. And so if it's too high of a problem, we may not ship the product. We may have to resolve that issue first. But the sooner you know is another source of value. It's much easier to make changes while you're in the design and development stage than later when you're already shipping the products. And so using that concept is another way to quantify the value of doing these tests earlier versus later and justify the resources you need to do the test. So we could spend a whole hour just on how we provide value in the design and development stage. And it's underpinned with that there's a competition for influence in the design team to actually make changes, to add money into the design, basically using more expensive parts for derating, for example. But if we can show the connection to the change in failure rate, we have a much better life cycle analysis. It's a very simple one, doing derating, to show that it makes a difference and that it can save us money on a later stage in the life cycle. Once we get into production and manufacturing, a lot of our focus turns to process control. And we work closely with quality organizations or quality teams, manufacturing engineers, with our suppliers. But the basic process here is to get the product out. It's balanced, though, with making sure that we're addressing the issues that would cause latent defects or would cause errors in the product to actually get to market. That also takes time and money to accomplish. Once again, if we can show that this will materially reduce our chance of future field failures, we have a chance to show that the life cycle cost of an investment in production is worth the returns during the use of the product for the customers. So I think you're seeing my theme here from a reliability point of view is oftentimes we're using a change in failure rate, but you can also use a change in time to show a value. So like my coffee machine, one of the values was that it took a lot less time to do a repair, to do a major repair. So if I can use fewer spare parts, if I can make the maintenance process user-centric rather than back at a depot or repair center, if I can shorten the installation or startup time, if I can avoid training by making it simple to use, all of those add value in the use of the product, the cost of ownership. And it allows us to quantify the improvements of doing simplifications to the design or the manufacturing process. The other end of, or the end of the life cycle is wear out and disposal. Now, some things cost money to dispose of. They're not, of value in and of themselves, but there's, I know here in California, we have a fee, I think the state, or maybe it's the county, imposes when you buy some electronics. If you buy a new computer, there's a disposal fee attached to it. Because at some point, the computer is going to be discarded, and it needs to go into a particular stream. Some of it is for recycling, but some of it is to keep hazardous materials out of the waste streams. And so there's a cost to that. So keep in mind that even at the very end, whether you're trying to extend the life of a system with major overhauls, which has cost, and minimizing that is a value, or the disposal costs. So avoiding the use of hazardous materials that require special handling at disposal, and safety gear, for example, decommissioning a piece of equipment, those add value by addressing those even as early as in the concept phase. So there's lots of opportunities throughout the life cycle for us to find ways to make a difference by doing what we do as reliability professionals. But keep in mind, you've got lots and lots of ways to impact that financial consideration for a FMEA study or a accelerated life test. It's pick and choose the ones that make the most sense for your organization. And what I usually do is pile on and say, well, this will save us yield in manufacturing, it'll save us field failure rates and warranty costs and use, and it'll reduce the cost of disposal later on if that proposal or change would actually do all those things in a reasonable way. Then you can add all of those values together. That helps your argument to win the day for it. So brace yourself for a little bit of MBA type stuff. And this is stuff I think you probably already are familiar with and may have heard in a number of cases. But this concept of return on investment, and in many organizations, is they have a guideline to say what is the threshold of ROI that this would be a investment worth doing. I know when I worked at Hewlett Packard in the manufacturing organization, it was a 20-to-1 ROI before we would consider it a viable investment. And so I wanted to buy a piece of test equipment, a scanning acoustic microscope that cost about $50,000. But I needed to show that it had about, what is that, $2 million of value if we got the equipment. And we used a combination of the time to do failure analysis and the avoidance of future failures. And it was just a probability that we would find something that we would resolve. So I gave us a 5% chance of finding a field problem that would affect 10% of our products. And because of the volumes and cost of our product, it was more than enough to justify the purchase of the equipment. And we actually did find some really useful things that more than saved us the $2 million. But the idea with ROI is like that graph I showed in the example is, well, there's some costs, some negative cash flow, and there's some gain, some positive cash flow. So tallying up at a very, very basic level is tally up how much it costs for the investment. What's it cost us to implement this proposal? And then what's the estimated return? What's the gain that we get back? And it's just this ratio. The downside to ROI is it doesn't take into account the time period. So if you ever see an ROI, it should be accompanied by over what time period. So I might get a 20-to-1 return over 10 years versus a 20-to-1 return over 6 months. And the shorter time period to that ROI is more powerful. It's a quicker return. So almost always see ROI combined with some time period. So another way to look at this is a cash flow analysis. And if you account for the time value of money, we'll look at that next, then it's a discounted cash flow analysis. Now this is commonly done looking at assets, the purchase of a major asset for a plant, or if for a financial analysis of buying shares into a company. So is it an income producing stock or bond, or is it simply capital appreciation? And where's the cash go and what's the return on that? So it's similar to a return on investment, but it's really only looking at, well, just that element of the cash flow. But it adds this time element of the time value of money, the discount rate. So at the moment, around the world, discount rates are pretty low. If I put my money in the bank and say a money market account or a savings account, it's often less than 1% return. But there wasn't that long ago that investments of 10% wasn't uncommon. So your organization probably has a working discount rate. How much return do they typically get on a conservative investment with the capital, the money that's available? And what's that return? So if I spend $100 today versus hold that money and return it a year from now, how much could I get on a conservative investment and say that's a 4% return? I need to do better than that. The other thought of this is that it's also dealing with inflation. And so $100 today is not worth as much as $100 a year from now. And so it accounts for the inflation rate. So organizations treat this usually with some fixed number from the finance group to say, here's how we discount future cash flow. And you can see in here that for each time period, say every month, in the coffee example, we saved about $480 on cleaning. Well, each month, that $480 is not worth as much as a dollar today. And so this formula is adjusting the future cash flows to today's dollars. We're putting them all on an equal footing. And so instead of a line with equal 480 blocks going out every month, those would slightly decrease each month according to the rate, the discount rate, how far out it goes. So it's a way to account for the time value of money, this cash flow analysis. And then the net present value is the natural extension to this. And basically, we're adding what's our investment at the start. And so I have my initial $5,000 in that initial example with the coffee machine. And then each month I have some estimated amount of savings that's discounted by some percentage. And so in time period one, if I have say a 4% discount, I'm dividing by 0.96. So instead of $100, it's going to be $96 of savings. In the next month, it's going to be the second time period, but now it has 2 months of application of that monthly discount rate. So it may be $90 or $91, something like that. And it just continues to decline as the discount erodes away the value of the future funds. And then we compare that to what our initial investment was, and it gives us the overall net present value of the period of time we're interested in. So there are more complicated ways of doing this, and making friends with somebody in your finance group is usually the best approach because they have these tools in and out all together. And they can help you. And sometimes they actually think these are fun projects to work on. And Sean, you're asking about is the discount rate accounting for depreciation of the equipment? No, not really. The depreciation, I know discount rate can be applied there, but that's a different set of calculations. And sometimes it's for tax purposes, but sometimes it's also related to the actual viability of the equipment. I've seen depreciation as an accounting method for the value of the asset within your organization. So if it costs $100,000 to install this new asset, there's some value associated with that, but between taxes and for accounting of that asset, if you tried to sell it, say 5 years later, you're probably not going to get the full value of that equipment. So think of your car. You might buy a car for $10,000 or the new Tesla 3 for $35,000. Now, within the first couple of months, it might actually appreciate in value as others couldn't get their order in quick enough and have to wait longer, and they're willing to pay a premium for it. But after a few years, that vehicle is probably not going to be worth $35,000 anymore. And that's the concept of depreciation, is what somebody else is willing to pay for it, for a used model versus a new one. Yeah, and thanks, Vinny. You're right. It's the discount rate is basically what you could do otherwise with the same funds. So you putting in a bank account is or some other investment that you have the option to do is usually where those numbers come from. Yeah, good question, Sean. So let's take a look at another example. And a bicycle. I'm actually working with Carl Carlson on writing a book on reliability engineering management, and we're going to use a bicycle manufacturer, a design and manufacturing set of examples throughout the book. So I'm starting to recast a lot of my examples into using bicycles. But let's say we're in a bicycle shop and we're making a product for a relative volume product, a relative high-end bike, and we want to make a change, but we know it's going to cost about $5,000, and we think it's going to improve the reliability of the product and reduce our warranty costs. So I'm using a fairly simple example. But the question is that the program manager is looking at the cost of this change and their design budget and is saying, is this worth it? Is it worth making this change for the future benefit if it materializes? So the first question that we need to ask is, well, what's the change in failure rate? So that assumes that we know what the existing failure rate is and then how this particular change manifests itself. So I'm using some round numbers here and say we do our due diligence as reliability professionals and we find that the material fatigue or the stress strength calculations or whatever technique we're using or testing we're doing would eliminate a problem that causes about 0.5% of failures per year. So I'm using some big round numbers, but you can see pretty quickly in the rest of this example that even a very small change in estimated failure rate over a year can have a pretty significant impact. But what other information do we need in order to flush out this life cycle cost analysis? Without peeking ahead to the additional slides, if you downloaded them, what else would you need to calculate the future value? And I'll give you the discount rate if you go to use net present value in cash flow analysis to make it a little more sophisticated. But what else would you need? So drop what pieces of information would you go look for? Useful life of the equipment. Now, in this case, if it's a warranty, as we're looking at, then it would be the warranty period, but also the useful life if you're concerned about the cost of ownership, cost of the spare parts or the maintenance. Yeah, the cost of the repair. It's good, good. It's one of the things that I think every organization should know is, well, what's the cost of failure that happens? So if I have a failure rate, I need to multiply that by some figure. Yeah, and Merrill, you're exactly right, is that business sense is over what time period? What's the ROI threshold and what time period, right? And then, Brian, you're talking about, I think you're talking about carry parts of new parts is the inventory costs. So this change may end up having to scrap our existing inventory if it's already in production, right? So the carrying costs of what do we do with the old stuff? What do we do with new ones? If it's a spare part, how about inventorying? All those kinds of things. Yeah. Maintenance costs. So if this failure rate is affected by maintenance or is it a straight replacement? Either way, there's ways to sort out what those costs are. Yeah. Cost of downtime. Yeah, if this is in the Tour de France type bike and the guy can't ride for a stage, that's a pretty significant cost. For a recreational rider, it's not a big deal as far as cost, but it does impact customer satisfaction if your bike goes to the shop too often. Yeah, obsolescence. I think we're all on the right track here. Excellent. So here's what I did, just for a simple example, is let's say we know that a warranty cost, when somebody is complaining about a failure on their bike and it's under warranty, it typically costs us $600 to process and resolve the warranty claim. And we also need to know, and I didn't see it in the list, is, well, how many units are we shipping? So in this case, I'm rounding it off that we're shipping 1,000 bikes a month. So it's a moderate volume. and we've got a 5% defect or failure rate per year, and it costs us $600 per warranty claim. Yeah, logistics. So I'm rolling all of this logistics and parts and maintenance and repairs into this warranty cost claim. And it varies dramatically from organization to organization what gets included in warranty. So as you sort that out, look for those hidden costs like engineering teams and material review boards and the other actual costs to your organization may be beyond what you typically call a warranty cost. It can add up pretty dramatically. So I'll get my pen again. So what I laid out here, and you can find this information in each of your own organizations. Get rid of the green thing. Is I'm shipping 1,000 units in January, and I'm just going to look at 1 month as an example. And if I have an existing failure rate of 5%, I would expect 50 of those 1,000 units to have a warranty claim. Now, depending on your industry, this might be great or it might be horrible, but it's just a round number I made up. And so I have 50 warranty claims. They each cost $600. And if I did the math right, that's $30,000 in warranty claims. Well, that's just the 5% failure rate and what we would expect. So that's the baseline. If I take away 0.5%, I'm going to save $3,000 a month. So $3K per 1,000 bikes shipped, right? Well, that's not a whole lot, right? That's a very small amount per month. And if you add the time value of money, that's going to erode as you go further out. And so as I calculate the additions of 3K roughly going out, it's going to take me about 16 to maybe 25 months or 16,000 or 25,000 bikes shipped before I get to even a break-even point for this investment. So the longer periods is dependent on how big your discount rate is. Yeah, and so 1,000 bikes is per month. And Kirk, you're exactly right. There's also a loss of reputation. So if this change to the failure rate is noticeable by the industry and it puts us in best in class, it may increase revenue and sales because that's a better position. But when it comes down to it's hard to quantify is the impact on future sales. So it's possible. It takes a little bit more work and some friends over in the marketing area. And so brand promise, reputation, increase revenue or decrease in revenue for a change in failure rate, all of those things matter. It's just I'm not including them in this example because they are difficult unless you've got some good research, usually by marketing and sales, to help you quantify those things. So in this case, the time it takes is, say, 2 years to break even. And I would argue that most organizations would consider that not a good investment. So it's time to start. And so the cost of the bike to the customer, let's say it's $500. Usually warranty cost is more expensive than the retail price. So to answer your question there, Christine. So the notion is that by looking at what's the impact, and all I needed here was what's the cost per failure in some form or fashion. Now, if I include reputation, this might be an order of magnitude bigger, and it would dramatically shorten our return on investment time period. But it's the same algorithm, is what's that change impact in future costs? And what change does it make? And then we can tally that up. We can do the time value of money to fancy it up a little bit. And if it's really important and really big numbers, not these small numbers for your organization, is work with your finance cohorts to sort out an appropriate analysis for it. But this is the basic thought process, is think through, well, what will this change impact? And how will that quantify itself into dollars and cents? So if I'm spending 50K and I have to wait 2 years to break even, there might actually be other things that I really should do that would have a bigger impact. It might have a different return. And I should learn how to use my pen and actually draw things correctly. But so one example, it was a slam dunk. It was easy to do. This one, not so clear. I may not have enough information, or it's really not a good proposal. But hopefully it illustrates just a quick and simple way to think through this life cycle cost analysis for what we do as a reliability engineer to help us justify investments in improving the reliability. So the basic idea is to think through in the general picture is that the earlier in the life cycle that we can make changes, usually the bigger the impact will be. It costs us less to change the design early than later in the program, and that alone has a huge impact on costs. But there's also a handful of financial tools available for us. And I think I've had two calculators from HP in my lifetime. One was a financial calculator that had this net present value calculation, this cash flow analysis with discount rate built in. You'd set the discount rate and then you do the calculations over how many periods, and it just cranked it out for you. It's probably where I learned it first, was in college. And then I also had a scientific calculator for real work, is like the way I like to call it. But they do overlap. Is we can make a brilliant proposal to reduce the failure rate by 0.5%. It may not be justified. And to help our decision makers and to help our teams is we need to understand what the overall impact really is so that we can actually get changes made that actually make a difference to the organization. Most of us work with worlds where cost and profit matter, but you can also do it other ways. So Harriet, I see your question on a spreadsheet to do these. The formulas are pretty simple. I found when I was trying to write an article on this a few months ago, I found a website called Investopedia. Let me add it here to the and I think it's a .com. Has many of these different tools and techniques, and I think they also have some calculators built onto their site. And it talks about all kinds of other types of tools like the internal rate of return, return on equity, return on capital employed, a bunch of other ones. And it provides a handful of algorithms and tools. I think there are some spreadsheets or online tools available. But the formulas themselves are pretty straightforward, and Excel is probably an appropriate tool for these. So a quick example, a little bit of a walk down of where we can apply these things with the stages, and just a brief introduction to the financial tools for us. But thinking through ROI and the net present value of money helps us make a very solid, justified proposal based on information that's important to your organization. I think I actually just summarized myself. So if you're making a proposal, is, look up the info. What's the cost of failure? What are estimated future failure rates? I go to Behringer's site all the time for industrial equipment like pumps and valves and actuators and all kinds of stuff. And he has a range of Weibull distribution values, characteristic life and beta is the slope, to help you do the future failure rate estimates. Now, some of the things have huge ranges, so it's going to probably take some further work to get it, but you can get a sense of where you're at and where you are in the ballpark. But run the calculations. Don't just propose, say, a $100,000 accelerated life test unless it actually helps you impact a decision or the future life cycle costs of the product. and helps you to make informed, valuable decisions. I think that's the whole point. So I think that's, yeah. Let me go to my wrap up one, which brings back the links for the slides, which is in a third block down on the right-hand side of your screen. And below that is links for more information, back to how to connect with me, to the webinar series, the monthly announcements. If you're not on that email list that goes out once a month and includes webinars and from every source we can find. My wife and I put that together, and she does the bulk of the work now. But we searched, I think, close to 20 different organizations that provide webinars related to of interest to reliability professionals. And so you get a one email that lists your next month's professional development. I put mine at the top. We put ours at the Sacendo Reliability at the top because, hey, it's our list. But other than that, it just lists all of the stuff that's coming up. It's a pretty nice list. I'm also, you're familiar with the Sacendo Reliability, and I mentioned it at the start. So please take a look at the site. If you're not already a member or on the email list, I send out a weekly update that lists the new podcast episodes, the new articles, and new courses, any new information that's available that's been posted in that week on this site. And so you can keep you up to date on what's happening with the site and what's new information available. And there's resources available, lists of higher education, different books. There's courses. There's a free course for just being a free member. There's a couple of courses that are paid that are much more extensive, and we're adding more courses as we go. So take a look at Sacendo Reliability. Let me know what you think, and let me know what questions you have for your professional development. And I'll be happy to address those as best I can. Yeah, and let's see, Vinay, I agree. Behringer's site is great. He's got all kinds of wonderful information there. And he tends to focus on industrial stuff. I think that's where most of his experience is. But the same principles, same ideas that we've been talking about today apply there. So let me know if there's any questions. I think I rambled on quite a bit in this one. I'd like to hear what your thoughts are or any other questions. Thanks, James. Appreciate that. And having that panic moment just at the end of me. I do see that this was recorded and it'll be available on a podcast in a couple of days, and also under the reliability.fm on the episode page is a recording. All right, so I'm getting a couple of thanks and stuff, and I'll end the recording and thank everybody for attending. I think this was one of the better attended sessions we've done, so I think it's a topic we'll probably come back to. But look forward to next month. Next month's webinar in May is on how to be an effective reliability engineer, or efficient or effective, I guess, one of those terms. A little bit more about your career and the tool sets and skill sets you need to be effective at what you do. So hope to see you at that one. So let me end the